Hello, and welcome to today's webcast brought to you by LEDs Magazine. I'm Editor-in-Chief Maury Wright. It's my pleasure to host today's event, The Future of Lighting, Harnessing Power over Ethernet for Intelligent LED Lighting. Our presentation today will come from Alec Magdessian. He's Director of Business Management for Mass Market Solutions at Maxim Integrated Products. Just real quickly before we get started, a few announcements to make. First, I would like to thank our sponsor, Maxim, for making today's presentation possible. I'd remind those of you in the audience that the presentation is meant to be live and interactive. You can ask a question at any time just by going there to the Ask a Question area in your presentation window and typing it in, click Submit. No need to wait till the end till we actually get to the Q&A session. If you're running pop-up blocking software, we'd recommend you disable it to view the webcast best. In fact, it's best if you close down all other applications for the best performance. We do now support platforms other than PCs and browsers. You can view our webcast with Apple tablets and phones running iOS 4.2 or later. In fact, you have access to both the live and the on-demand web presentations from those devices, as well as always from your PC and browser. And for your convenience there in the audience, the presentation will be available on demand within 24 hours. You'll be able to log back in and watch it if you want. We'll send you a reminder email with a direct link to the website. You can always get to all of our webcast archives by going to ledsmagazine.com. Just go up to the top navigation and find the webcast icon and click through to it, and you'll see all of the archived events. We have some resources for you today. Over in the lower left of your presentation console, there is a resource section, event resources. You can get a PDF of the slides that are going to be presented. Also, there's a white paper you can download today on the topic as well. Our speaker, Alex Magdessian, has more than 15 years of experience in the semiconductor industry. He's worked in a number of roles, including application engineering and marketing and business management. And in addition to working for Maxim, he has experience with Texas Instruments and National Semiconductor. He has a MSEE and a BSEE degree from the University of Texas at Austin. Hi, Alec. Welcome.
Hello, everyone. Thanks, Maury. And thank you, everyone, for joining this webcast. And today we're going to discuss the future of lighting and how Power over Ethernet, POE, enables a new frontier in LED lighting. So our agenda will cover four main areas. First, we'll discuss some basic POE concepts and terminology. Then we'll discuss LED lighting and why it offers a compelling area for integration with POE. And finally, we'll briefly describe a POE powered LED lighting reference design. So let's get started then with trying to get familiar with POE. Most of you know already that Power over Ethernet is used in wired Ethernet local area networks to deliver power and data over the same cable. Power may be carried on the same conductors as the data, or it may be carried on dedicated conductors on the same cable. The obvious advantage of such an arrangement is that you only have to lay down a single cable for both the data and the power. Now, some typical devices that we've all seen include voice over IP phones, IP cameras, point-of-sale equipment, network routers, intercom, entry access control points, and even 4G LTE WiMAX access points. So what are the advantages and benefits of POE? Listed here a non-exhaustive list of advantages. Already alluded to a few of them already, but they're worth reiterating. Cost savings is a big one. Installing an AC power line requires a licensed electrician, which could cost up to $1,000 per line. Having the power and the data on the same cable also means that the end equipment can be made smaller. Power is now available wherever there's an Ethernet connection. The fact that devices follow a known spec does also ensure that they work together seamlessly with no issues. Another benefit is the fact that the POE voltages are much safer than mains or offline AC. No one would argue they would rather work with the nominal 48 volt DC than with 110 volt AC or 230 volt AC. POE also allows the devices to be part of the IT network, such that they can be controlled or even turned off whenever required. There are three standards we care about for this discussion. The original POE standard, or IEEE 802.3AF, ratified in 2003, provides up to 15.4 watts of DC power over 2 pairs. POE Plus, ratified in 2009 as IEEE 802.3AT, provides up to 30 watts of DC power, again over 2 pairs. Finally, Universal POE is yet unreleased, and which provides more than 60 watts of power over 4 pairs. Let's introduce some terminology. Power sourcing equipment, or referred to as PSCs, is a device, for example a switch, that provides power on the Ethernet cable. When the device is a switch, it's usually called an end-span, although IEEE 802.3AF referred to it as an endpoint. Otherwise, if it's an intermediary device between a non-POE capable switch and a POE device, it's called the midspan. An external POE injector is an example of a midspan device. Hopefully this graphic here illustrates the relationship between the switch, the POE injector, and the PD. That leads us straight into what a PD is, which is a powered device. It's powered by a PSC. We covered some of the widely available PDs in our first slide. An LED bulb or fixture drawing power from the Ethernet cable would be another example of a PD. It is worth noting that a PD can have an auxiliary power connector for an optional external power supply. Depending on the PD design, some, none, or all of the power can be supplied from the auxiliary port, with the auxiliary port sometimes acting as a backup power in case POE supplied power fails. Now, and to a certain extent, it does kind of defeat the purpose of the single cable, but in some cases, there is no way around it, specifically in cases where the PD needs more power than the PSC can supply. In a POE endpoint insertion implementation, the PSC uses pairs 1 and 2 and 3 and 6 for power distribution, as you can see in this figure. The power in an endpoint configuration is supplied as a common mode DC bias on the cable pairs, while the Ethernet data is transformer coupled and is fully differential AC. In this configuration, the power and the data share the same pairs of cable. In endpoint configurations, the Ethernet magnetics are specially designed to withstand the DC bias resulting from the power. In a POE midspan insertion implementation, the PSC uses pairs 4 and 5 and 7/8 for power distribution. Power is distributed directly through the unused pairs in a midspan configuration for 10/100 megabit Ethernet, as we can see here. The positive PSC output, V+, is connected to wires 4 and 5, while the negative PSC output, V-, is connected to wires 7 and 8. In this configuration, the power pairs are separated from the original signal pairs, which pass through the POE midspan power injector. The midspan power injector is useful in installations where there's already an internet connection and it's too expensive to change out or upgrade the internet switch router to provide the POE power. Well, how much power are we talking about? How much power is available? Well, in this table, I've listed the voltage ranges and the maximum power delivered by the PSC and the power available at the PD. The drop in voltage and power between the PSC and the PD is due to the cable losses. Let's look at an example. For a Cat5 cable, the Ethernet spec calls for a maximum of 9.8 ohms per 100 meters, which is about 3 ohms per 100 feet. So if you wanted to get 9 volts at half an amp at the end of a 100-foot cable, we'll need to inject 12 volts because there's going to be a 3-volt loss, potential of a 3-volt loss across the cable. And just to calculate the 3-volt, though, just remember that the cable length has to be multiplied by 2 because you need to calculate the total resistance of both the plus V and the return cores of the cable. So for this 3-volt drop, here we've got a 6 ohm resistance by half an amp of current. The PSC is not allowed just to turn on and forget about the 48 volts. Instead, it periodically probes its Ethernet lengths to see if a PD that requires power has been plugged in. This is called the detection phase, and this is how it works. During the detection phase, the PSC relatively slowly ramps up the power from 0 to 10 volts at a rate of 0.1 volt per millisecond. During the detection phase, the current allowed to flow is limited to 5 milliamps in case there's a short or a problem. As the voltage goes up, the PSC measures the current flow at 2 levels, at least 1 volt apart, to determine whether there's a PD by looking at the detection signature resistor. 2 measurements are usually required to factor out the DC offset from the cable loss between the PSC and the PD. If the PSC detects an open circuit, nothing's plugged in, or it's a non-POE device plugged in, or even if there's a short circuit or anything other than the specified detection signature resistance, it doesn't turn on the power and repeats the detection sequence over again. Assuming that a valid PD is found, the PSC continues ramping the voltage as it passes between 15.5 and 20.5 volts. The PSC and the PD enter what's known as the classification phase, where the PD is given the opportunity to request a particular amount of power. Again, that involves the PSC measuring the current flow, this time across the classification resistance. It's worth noting that from a PD's perspective, the classification phase is optional, where full power is the default. But a PD that volunteers to accept a lower power level is, it's more welcome, quote unquote, by the PSC, because it has to allocate its maximum power delivery capability across many ports. Knowing that there's a PD requesting power and how much that power is PSC ramps the voltage and current limit to their full specs. Now the PD, it's got to be able to accept the power either on the data or the spare pairs, but of course never on both at the same time. The IEEE standard specifically disallows PDs that don't accept either power delivery options. The spec requires that the PD monitors the input voltage and turn on the load after it reaches 42 volts. Now the PD must disconnect the load if the voltage falls below 36 volts. That's called a under voltage lockout. That 6 volt of hysteresis is to compensate for the voltage drop across the cable once the PD is drawing full power, and there it causes a voltage drop. Some of the information on the previous slide is repeated here just to be able to compare it with the not yet ratified IEEE 802.3 BT. This new IEEE 802.3 BT extends the POE power capability up to 90 watt. New power classes have been defined to accomplish that. From a cabling point of view, in most cases, the maximum distance from the switch is 100 meters. Having a midspan in between doesn't change that distance, although a POE repeater can be used to extend the distance for another 100 meters. Which cable to use will depend on the network, of course, and the maximum data rate. As the category number gets higher, so does the speed and bandwidth of the wire. Obviously, it's not a coincidence. Each category brings more stringent testing for eliminating crosstalk and adding isolation between the wires. So Category 5 cable was revised, mostly replaced with Category 5E for enhanced, which didn't really change anything physically, but instead applied more stringent testing standards for crosstalk. Category 6 was revised to Cat 6A for augmented, which provided testing for 500 megahertz communication compared to Cat 6's 250 megs. The higher frequency eliminated alien crosstalk, which allows for longer range at 10 gigabits a second. Well, just as a quick note, for those who are not familiar with the term alien crosstalk, that's interference that can occur in a cable that runs alongside one or more other signal-carrying cables. The term alien comes from the fact that this kind of crosstalk occurs between the cables in a group or a bundle rather than between individual wires or circuits within a single cable. This slide is courtesy of New LEDs. They were gracious enough to let me use it. There are a couple of options when it comes to Ethernet wiring. There's a centralized option and a more distributed option. Each has its advantages and disadvantages. Scattered switches tend to be easier to install, have shorter cables, and therefore less cable losses, and easier access. On the other hand, they can be costlier from a total system cost point of view. And also, the lighting installer, for example, may not always know where all the switches are located. The centralized option is likely the one required by IT departments. You always know where they are. They're easy to locate. The downside, that in some cases they could be located further farther than where the PD needs to be installed, creating max length issues and cable loss issues. Now we're going to discuss LED lighting and the opportunity that the marriage of LED lighting and POE presents to manufacturers, suppliers, and designers. I don't have to tell you guys that the market is on a clear transition path from traditional lighting technologies to LED. The share of LED lighting in the general lighting market is expected to continue to grow from about 45% to 70% by 2020. Some of the reasons behind this growth, well, for one, regulation across the globe has become more stringent. That regulation includes the phase-out of incandescent bulbs in favor of more energy-efficient light sources. There's also a shift away from nuclear energy in some countries. The trend away from nuclear energy is expected to continue, giving a boost to energy-efficient lighting, which obviously fuels further LED penetration. Another reason is that LED prices have eroded more aggressively than was thought a few years earlier, pulling forward the payback time of LED lighting. Finally, it's easy to recognize the benefits of smart lighting, not only to minimize energy consumption, like with the addition of sensors like ambient light sensing, occupancy sensing, to dim and turn off the lights, but also to expand the concept through network lighting, which allows for a more efficient ecosystem. One implementation of network lighting is to assign an IP address to each bulb or fixture and have the entire lighting system as part of the IT system. We'll talk about this in more detail in a little bit. So how big is the potential opportunity for POE-controlled lighting? Let's take a look at the expected number of new installations in commercial buildings. In this graph, commercial is defined as office buildings, shops, and hospitality establishments like hotels or convention centers. The graph doesn't include categories like residential, outdoor, or architectural lighting, which at least in the early stages are not necessarily a natural fit for POE lighting. According to McKinsey, in 2012, there were 311 million new installations with a 6% LED penetration rate for a total of 18.6 million new LED installs. By 2020, this is expected to go up to 431 million new total installs, with a 58% LED penetration for a total of 249.9 million new LED installations. So, reiterating the number from the previous slide, we expect 250 million potential new POE-powered LED fixtures by 2020. Not too shabby. So let's move on and talk a little bit more about POE-powered LED lighting. There's a lot of buzz around POE lighting, and justifiably so. Pasted a couple of articles in addition to a Philips press release from last year highlighting all the buzz and all the work that Philips is doing in that arena. Since then, the world's first POE-connected lighting system was installed at a building developed for Deloitte in Amsterdam. And this system, and I'm quoting here, this is directly from Philips, quote, provides high-quality illumination while acting as an information pathway giving users personal control of lighting and providing insights on building usage for greater efficiency." End of quote. Oops. Yeah. Lighting is a natural system to host many of the sensor systems that make for a more intelligent environment. Some of these sensors are ambient light sensing, occupancy, temperature, environmental sensors like smoke or carbon monoxide, security, and access points, routers access points. Obviously, once you add a sensor to a lighting fixture, it adds to the initial cost. But the reality is, though, once you've accepted the cost of a sensor and a controller integrated with the LED light, it's only a small marginal cost to add additional sensors and modules to the assembly. Integrating additional functionality into the lighting fixture does save system cost, especially in the long run. Adding a new sensor or module to the smart LED bulb is a low-cost way to add new capabilities to the existing infrastructure without an expensive lighting replacement. So, as we move forward and the capabilities on the IoT Internet of Things continue to emerge and mature, the benefits of being able to quickly implement those must-have capabilities will accrue to those facilities that are using flexible, future-proofed installations such as LED lighting on a POE network. A simplified illustration of this connected office shows all the lights, sensors, and dimmers connected through the Cat5 or Cat6 cable. What's not shown here is any wireless control that's now available to any smartphone connected to the same network. If we wanted to summarize the benefits of the POE connected lighting system in a single sentence or slogan or catchphrase, it would be monitor it, measure it, and control it. So, what are the benefits then? Powering the lights for POE makes light fixtures plug and play with the standard RJ45 connectors. Installation and cabling is lower in cost and safer than offline AC voltage. And lightings now can also be fully configurable. Using an LED lighting PD on a POE network also delivers better energy efficiency because it minimizes inefficient power conversion stages for LED lights used in retrofitted legacy AC power sockets. But what is the most compelling is that lighting now is part of the IT infrastructure. As such, again, recalling our catchphrase, it's easily monitored, measured, and controlled. With the addition of sensors, facility managers can easily collect data on room occupancy, temperature, humidity, allowing them to improve building energy management, while office workers get to control their lighting and temperature through their connected smartphones. Powering and controlling LED lights over a POE network creates the opportunity to use the LED lights in even more new and novel ways. I mean, we've covered in a way, you know, if LED lights, how they can be your primary lighting. But in addition to being primary lighting network in a building, POE-based LED lighting can be instantly repurposed and used to provide important lighting, for example, during a power outage, without the need for a specialized secondary lighting system. Of course, it assumes that there's an appropriate battery backup or emergency power generation, which is usually already part of the network installation. The LED lighting can also be used to communicate important and possibly dynamically changing information to the building occupants. For example, to show the safe exit path out of a building, or show areas of the building to avoid, especially if the LED lighting can be commanded to change color by the LED controller already installed on the POE network. Another way is, which is already fairly common, is to couple the LED light to adjust with a controller so that the LED light can adjust its brightness and color and to provide consistent lighting environment as the ambient light changes throughout the day. Installing smart LED lights in the POE network creates new ways to interact with the building for the facility managers and the occupants. Facility managers can use the smart LED lighting system as an information collection network that allows them to collect historical and trend analysis, to know how to better adjust temperature, ventilation, lighting, even cleaning schedules by how occupants actually behave and work in their environment. Of course, the occupants can also use the smart LED lighting system to access other building services like proximity sensors and to find a closest available meeting room. Items with RFID tags can be tracked if the smart LED includes modules for activating and detecting the tags. Smart LEDs with wireless access points can be used to set up short-range wireless networks. The perfect fit with POE makes it the future for LED lighting. POE enables LED lighting networks to use a power supply that operates alongside a building's legacy power infrastructure. And possibly the largest benefit of installing smart LED lights in a POE network is that it provides a form of future-proofing because the lighting, power, and data wiring is already installed where the people need to be. Here's a typical block diagram of what a POE Powered LED Driver board could look like. The PD controller provides a signature to the PSC to enable POE. The PD controller then powers the LED driver and any additional components required, like a DC to DC converter, a processor, or whatever else is on that circuit. Now, to minimize the number of components, it's best, after all, everything has to fit within the fixture, which may have some space issues, space limitations. It's best that the LED driver can withstand the POE voltage spec of up to 57 volts. Otherwise, you'd need to use an additional buck converter, for example. Also, it's ideal for the LED driver to integrate as many of the external components. Should also be able to provide as much power as is available and be able to protect against overheating with features like thermal foldback or thermal shutdown. A question that seems to come up: does my fixture need to provide for isolation? The isolation is required between the Ethernet connection and the user of the equipment or any other connected equipment. Usually, that's provided by using a DC to DC converter with at least 1500 volts of isolation and an Ethernet isolating transformer also with at least 1500 volts of isolation. So in regards to a PD in general, the short answer is yes. The IEEE specification states that electrical isolation shall be in accordance with the isolation requirements between safety extra low voltage circuits and telecommunication network connections in subclause 6.2 of IEC 60950-1. However, in some applications can avoid the need to provide isolation if there is a 1500 volt isolation between all parts of the electronic and any shielding that may be used and all user accessible parts. So if the user can't get to it, it may be okay to not provide that isolation. If a plastic enclosure is used, there are no parts of the circuit that violate a 1500 volt isolation barrier, no exterior connectors or to other equipment, no user buttons that fail to provide the isolation, no internal conductive paint that's very close to the enclosure joints, then you would essentially comply with the isolation requirement elsewhere, and a less expensive non-isolated DC to DC converter could be used at the POE input. Finally, we're going to look very briefly at a POE Powered Lighting reference design. Maximus put together a lighting reference design where the bulb is powered by the Ethernet connector. We're using a Max 16832 LED driver and a Max 5969 PD controller. Dimming control is through a smartphone using Bluetooth. Keep in mind, to take full advantage of the IT network and in real-life application, control would be done through the IP address of the bulb. But for demo purposes, Bluetooth is easier to implement. Having said that, the board can accommodate various control options from an HM12 Bluetooth module to BL600 Bluetooth module, in addition to a Wi-Fi option with the ESP8266 Wi-Fi module. We're also working on an Arduino Shield, which will allow for IP addressing directly. So that's all I have for today. Thank you for your time. I believe we're going to open it up to questions.
Absolutely. Thanks, Alex, for a very good presentation. For those of you in the audience, if you haven't submitted a question yet, you can still do so. Just go to that Ask a Question area, type it in, and click Submit. And so we have a variety of different question types for you here already. Alec, some of them related to kind of how the negotiation works over the Ethernet network, and really a little bit of everything else. The first one is, how many times will the PSE look for the device, I assume meaning the PD, and will it continue to detect a device over time?
Yes, the answer is yes. It will continue continuously look for PDs.
And so essentially every PSE port is doing that constantly over their life.
Correct, it is. And one thing to keep in mind is that let's say, call it the probing current is a very low current. So yes, it is constantly doing that. Every port is constantly doing that.
And how long does the searching process take? I think that once again is focused at the PSE.
It takes about 300 milliseconds.
And so I assume the reason the question was asked was probably having to do with the delay in getting power to a device, but that doesn't necessarily translate directly to power on time of a light, right? If a light fixture was there connected to the network, had already been recognized, but at the moment was switched off by a smartphone, that delay would not apply, right?
Well, yeah. Well, let me see if I can explain this a little bit differently. If the driver only, the LED driver, is the only thing being turned off to turn off the light, then that delay isn't affected because the PD is already recognized, and the PD is on. And so as soon as the LED driver comes on, then the bulb is on. But if the PD is turned off, then you basically have to account for that time between the PD turning on and then the LED turning on.
Well, I guess in a typical building, would turning a light off, say with a smartphone, would that really equate to turning the PD off or turning the driver off? Or is that really an implementation choice?
It would be more efficient to turn off the PD.
Because you don't waste any energy on that PD sitting there at some low current percolating away.
Correct. Correct.
This is a question about the efficiency of the scheme in general, and you talked quite a lot about the resistance of the wiring and the voltage drops you have to accommodate. But is there an efficiency issue here at all because of the voltage drops in this computer cable that really was designed not to carry high voltages, and when you compare it really to an AC line, would it be considered would the efficiency be considered a problem?
Well, I mean, I'd have to do the exact calculations, but it would be slightly less efficient than the AC lines. I can't tell, off the top of my head, I can't tell you exactly what the efficiency penalty would be.
I would, I would be speculating as well, but I would think that any efficiency penalty associated with cables would be more than compensated for by the distributed power scheme in general, where you aren't doing AC to DC conversion in every single luminaire.
Exactly. You hit the nail on the head there, Maury. You're taking out basically a AC to DC converter in every bulb luminaire fixture, and that efficiency loss is now taken out of the equation.
So you talked about all the different power classes of POE devices, and I know a couple of the different tables, there were two 13-watt classes. It was like a class 0 and I think a class 2 or a 3. Why are there two at 13 watts?
Let me get back there. Let's see.
I mean, what I wondered was, is the class 0 really just a startup thing and not really a power class?
Class 0 is more of a default class, and there's really basically there's really not been any classification per se at that point. And then once it's the default class, where if that that's basically it. It's a default class.
This person said, I've seen references in specs that PSE voltage is -48 to -54 rather than in some reference design specified it as +48 to +54. How or why is the negative source voltage necessary, and which is more complex to generate supply? Can you address that?
So it's a question of what the reference is. It's not a question of necessarily a negative voltage.
This person asked that the main downside to this approach, and I think they mean power over an Ethernet in general, is the requirement for backup computers or a backup remote smart device to take over when the main system fails. I think what that comment means, and I've heard this question, if I'm reading it right, before, is really, can you trust your lighting in a building to a computer switch? I know we rely on our computers quite heavily every day in our jobs, but we know when we turn that light switch on that the lights are going to come on.
Yeah, I mean, it's a fair question. If you're talking about, power outage, most computers have, most systems have backup power. So, I mean, I would think power outage is less of a concern. If you're talking about, for example, just a system crash and such that now, addressing this specific lighting fixtures is now, is now kind of messed up, and that's a more, fair characterization. But you can also have some backup systems to make sure that doesn't happen also. Or you can have
also,
basically a secondary backup lighting system.
Right. When you were talking about the auxiliary power, so do I understand correctly that one possible functionality is a backup kind of power, but that in some cases you would expect the luminaire to share power to get some amount of the power from power over Ethernet, but to get whatever its additional power needs from some auxiliary source?
That's not quite how I described it, Maury. Basically, the idea, I mean, in an ideal world, it's getting all its power from the switches. But the idea is you can repurpose, for example, to repurpose it from general lighting to a specific, let's say, only lighting, let's say, exit paths or so on. That's more of the idea, as opposed to trying to draw power from a different source. Because I mean, so the idea is if you're gonna lay down AC cables, then maybe the benefits you're not getting all the full benefits of the DC powered lighting.
No, I understand that, and I don't think there's any question of that. I just wondered if the conception was maybe if you had one luminaire in an area that just needed a significantly higher power rating than what POE could deliver, if that was the thinking there. But it sounds like it really more is a true auxiliary power for specialty applications.
Yeah.
This person asked, does the U.S. electrical code need to be changed to accommodate power over Ethernet for lighting? They go on to say there's a proposal to address communication PDs in new section to Article 840, but it doesn't seem to address lighting. Is that a technicality, or is there a need for a code change?
Oh, I'm afraid I'm not qualified to answer that question. I don't know.
Also,
that one stumps me.
Yeah, well, perhaps we can find an answer and get that question to the person via email.
Yeah.
When you talked about the different cable types and the different sets of pin pairs, if I understand it correctly, the PDs it's a requisite that they can take the power over either the data pairs or the unused pairs, right?
Correct. Yeah.
But was there not some evolution to, and this may be what this person was asking about, but was there not some concept at least to continue to evolve power over Ethernet to combine both of, to combine both the data pairs and the unused pairs to continue to ramp the power level up? Or am I remembering something that did not happen?
That's, I mean, unless I misunderstood the question, I mean, that's the whole idea with the 802.3 BT standard. Maybe I misunderstood the question. I mean, now you're, with Class 7, now you're able to, have 90 watts of power to be delivered to the PD. And I would think for lighting purposes.
So it is using both the data pairs and the unused pairs.
Yes.
Okay. And this attendee had said you did not mention power over HD base T, and that's a term I'm not familiar with, but they said, is there a difference between UPOE Class 7 and power POH? Power over HD base T.
That's another one. Not sure.
Okay. So this is specifically a question about with your, I think your LED driver IC product. What's the efficiency of the 16832 LED driver?
Upwards of 84%.
And this says, what changes are needed for the RJ45 connector to actually handle 90 watts of power? Will there be special coatings or tighter connector tolerances?
Yeah, I mean, likely. That probably will be called out in the new spec. Over the years, the cables are also kind of changing. I mean, even the way the pairs are twisted between Cat 5 and Cat 6, where Cat 6, granted that's more for interference, but yeah, some changes will be required. Specifically, I'm not sure, but that will come down to once the final spec is released and what those changes will be. But
yeah,
expect some changes.
Yeah, well, and that's exactly what we've seen from Cat 5 to 6 to 6A, as you said, right?
Yeah.
This person asks, is there any play for power over Ethernet in outdoor installations, or maybe maybe even if not in traditional roadways, but for more tighter area lighting applications?
I mean, there is. I mean, the issue will be the ability to withstand the environmental conditions and also the distance. Once you get into the outdoor world, there's other limitations that you may not have within an enclosed building. But nothing that can't be overcome. But my expectation is that it's likely to be a while longer before outdoor is added to the equation. Today it's outdoor. Yeah, I mean that really is. I mean I think that potentially could be the next frontier after that. But I think POE lighting probably needs to prove itself as an efficient, as a good way to do lighting. Before it kind of migrates to the outdoor.
This person, was asking about the reference to design, but wondered, in addition to the PD side of that equation, if you guys have any reference designs for the PSE side of that link.
Well, I mean, there are on our website. There's many PSE reference designs. They're not specifically to lighting. But yeah, there's definitely some on our website. I mean, the nice thing about this PD reference design is that you just plug it in into the wall, into the RJ45 outlet, and then say, let there be light, and it lights up. Nothing is required on the PSC side. Side, of course, that implies that the switch is POE capable. If not, then you'll need a midspan injector.
And I understand that it is a reference design and it's being used with a pretty simple, retrofit replacement type lamp, at least in the reference design. But with that reference design in place, how far could it scale in terms of using higher power and being used as the basis for a design in a luminaire?
Well, the bulb that we're using is less than 10 watts. So, as long as you can, use the appropriate driver and you are drawing enough, you're drawing the appropriate current, then you can go up to whatever. Well, based on what POE you have, 25 watts, or later 45 watts, 60 watts, 90 watts. Of course, it'll be less on the PD side, but whatever that equivalent is, that's really, in a way, your limit. The other way to look at it is, while each port has that limit, if you take basically a full, potentially a 24-port installation, multiply that by, let's say 25 watts, and that kind of gives you an idea of how big your switch needs to be, or how the power supply of your switch needs to be, because ultimately that's where the power is coming from.
In regards to how the PD devices are identified on the network, and realizing that your Bluetooth implementation in the reference design was purely done for convenience, does every LED fixture ultimately need to have an IP address?
No. The answer is yes and no. No, if you want to control them as a group. Yes, if you want to control them individually.
So they could share an address if they were going to be controlled in a group.
Correct. If they want to be dimmed in a group, turned off in a group, turned on as a group, then they can, of course, share an IP address.
And one person asked, what is the lifetime expected for a PD? That would not really be relative to the POE technology, but more of the same consideration of a regular LED-based luminaire, right?
I'm sorry, Maury, I didn't quite get that question. The
lifetime of a PD. Yeah, I mean, because the PD wouldn't have anything that would be a shorter life than.
Yeah, I mean, it wouldn't. So normally, in a bulb, the passives are more likely to fail than any of the ICs. So the LED driver, the LEDs themselves, or the PD controller, any DC to DC converters, these devices, are not likely to fail. The passives, specifically like electrolytic capacitors, if there are any, are more likely to fail, if so. So, I mean, there's no limitation per se on the lifetime of a design.
So we're getting close to the top of the hour. So I'll close with this question, and this was really asked in several different ways in the list of questions. But you mentioned obviously the Philips Deloitte building. What do you expect in terms of other installations? Are there any other installations out there that you know of? When would you expect commercial installations? And I guess ultimately, I think the Philips project was a pretty customized luminaire. When would you expect actual commercially available lighting products that are based on a POE input?
Well, there are already commercially available lighting products based on POE. How quickly, I mean, company like New LEDs I believe is doing some installations based on, for POE lighting. There are companies out there providing that today. How quickly will they become more common? I'm not sure. I can't answer that question. From Maximus' point of view, we're providing the LED drivers and the PSC and PD controllers, but we think that this is a very exciting area, and there's all indication based on what our customers are asking us for new LED drivers or new PDs, that this is an area that's poised to grow fast. But I guess more than that, I don't really. Some of the guys listening in probably know more about it than I do.
Okay, well, that's a good place to end. But I agree with you. I think it's going to be a very, very exciting area to follow in the next couple of years. So on behalf of LEDs Magazine and Pinwell Corporation, I'd certainly like to thank Alec for a very good presentation and good job dealing with a lot of different types of questions today. Thanks again to Maxim for supporting today's event. For those of you in the audience, I'd remind you that the presentation, The Future of Lighting, Harnessing Power over Ethernet for Intelligent LED Lighting, will be archived by this time tomorrow. You can access it from our homepage, or we'll send all registrants a direct link, and you'll be able to get to that anytime you want for the next 6 months. And for those of you in the audience, I thank you so much for joining us today. We certainly know your time's valuable. We appreciate you spending it with us, and we look forward to bringing you future webcasts. Have a great day.